Let's have a look at exercise 4b. 1. Find the distance between each pair of the points given below. So given 2 points, we just substitute them in. Now it does help, if it helps you by writing x1, y1 over the top here and x2, y2, that would be great. So we're using this, and we're going to put all that in. So I've called this x2 minus x1 squared, and y2 minus y1. Be careful of the double negatives here. And the first one is 9.71 to 3 significant figures. Now B is 3D, so we've got x, y and z. I'm going to use this formula here. And so that says AB, like this says D. That could have just as well have said AB. This could say D. So we've substituted all the numbers in here, and I've used this as x2, x1, y2, y1, z2, z1. We come up with 8.83 to 3 significant figures. Question 3. The vertices of a sail are plotted on a pair of coordinate axes and have the following coordinates, A, B and C. Show that the triangular sail ABC is shaped as a right-angled triangle. Well, the first step is to find the lengths of each side. So we find AB, then we find BC, and then we find CA. Once we know all the lengths, and you can see that AB and CA are the same lengths, right, we've just substituted them into the distance formula. Now it says, assuming it is a right-angled triangle, BC is the hypotenuse because that's the longest side. Remember, in a triangle, a right-angled triangle, the hypotenuse, the one opposite the right angle, is always the longest side. So BC squared should equal AB squared plus CA squared for a right-angled triangle. And we've got 15.23 squared. And on the right-hand side we have this. Left-hand side does equal the right-hand side, therefore it is a right-angled triangle. In fact, it's an isosceles right-angled triangle in this case because AB is the same length as CA. Question 4. A fountain has a circular shape. The diameter of the circle has endpoints A and B. Find the circumference of the fountain. Okay, the endpoints are on the circumference. So A is 1,7, B is -2, 1. So that we find the distance, and that'll give us the diameter because they say that's the endpoints of the diameter. So we're using this one. I've got this one here as x2 and x1. So it's 1 minus -2 squared. y2 minus y1, so that's going to be 7 minus 1 all squared. That's the square root of 45. Okay, since AB is defined in the question as the diameter, so the radius is half of that, so it's the root 45 on 2. To find the circumference of the fountain, we know that the circumference of a circle is 2 pi r, therefore the circumference of the fountain is 2 times pi times r, which we said was root 45 on 2. The 2's cancel, and we've got pi times root 45, and the answer is 21.1 to 3 significant figures. Now we didn't have to actually use the radius, we could have used the diameter because the alternate form of the circumference of a circle is pi d, because remember 2 times r is d, so pi d is also, we could have just multiplied pi by that, and as we see that's what we have here. 5. Carrie makes a kite in the form of a parallelogram, EDGF, as shown in the diagram. Its diagonals DF, so diagonal DF, and EG intersect at the point H. She plots the vertices on a coordinate system with the following coordinates. D is 3, 6, G is 1, 3, H is 4y, and E is x6. Find the values of x and y. Well, what we need to know is the diagonals of a parallelogram. Now I've taken this from Maths is Fun. The diagonals of a parallelogram bisect each other. Now bisect means the diagonals intersect each other at the halfway point. So if they intersect, if that's the same length as that, and this is the same length as that, we can say that if we were to draw a line parallel to the sides of this parallelogram, that the horizontal distance between H and G is the same as the horizontal distance between H and E. So if the horizontal distance between H and G is 4 minus 1, that's 3, then we need to add 3 to the 4, and we get that x equals 7. Okay, if you put this on graph paper, you would be able to see that. So now that you know x is 7, we have enough information to find the midpoint of G and E, because G is 1, 3, and E is 7, 6. So the midpoint's the average of the x values, so that's 7 plus 1 divided by 2. And the y value is 6 plus 3 divided by 2, and that's 4 and 4.5. And we know that the coordinates we're given is 4 and y. So if 4 equals that, then y equals that. So y is 4.5. Question 6. A tracking station lies at the origin of a coordinate system with the x-axis due east. Okay, so this time we've got the x-axis east, which is a little bit different than some of the diagrams we have in the book. So be careful with x and y. Z is generally straight up. Okay, well, that's directly east. The y-axis is due north. So if that's east, that's north. And the z-axis is vertically upwards. So it's z. Make sure you label each axis. 2 aircraft have coordinates 20, 25 and 11 and 26, 31 and 12 relative to the tracking station. And they told us the tracking station's at the origin. A, find the distance between the 2 aircraft at this time. If we have this in 3D, these points of one aircraft and those coordinate points of another aircraft, and we just need to find the distance, in the formula booklet you'll find the distance formula, and we see what that is. So that's the x2 minus x1 squared, y2 minus y1 squared, and z2 minus z1 squared, all square rooted. And that's the square root of 73, or to 3 significant figures, 8.54. And it doesn't say, up to here we don't even know it's the units, but over here we can see that should be kilometres. B, the radar at the tracking station has a range of 40 kilometres. Determine whether it will be able to detect both aircraft. Well, aircraft 1 to 000, so that's where the tracking station is. We've got to see if the aircraft 1 position, and that's our aircraft 1, if that position is within 40 kilometres. If it is, then the radar can reach it, or 40 or within 40. So we can put that in the distance formula, and we're using the aircraft position, that's 20 minus 0, because we're looking at the distance between the aircraft and the origin, 25 minus 0, and 11 minus 0. We put in there and we get 33.85262, which is less than 40, so that seems to be able to be detected by the radar. And aircraft 2 to the origin, okay, and we're going to use this point now because that's aircraft 2, so it's 26 minus 0, all squared, 31 minus 0, all squared, 12 minus 0, all squared, and it's the square root of that. So the distance is 42.20190, and that's greater than 40, so the radar cannot detect aircraft 2. Therefore, the radar will not be able to detect both aircraft. In fact, only aircraft 1.